Okay, welcome everybody. Looks like we're all here, all filtered in. Hi, I am Ken again. I need to put out a sign-out sheet. I'll do that. So don't forget to sign the sheet before you leave. I'll put a piece of paper out. I didn't do that. I was chatting with these guys. So welcome to the weekly Conservation Sciences seminar again. As usual, we have a really diverse and eclectic range of topics. This was one I thought was really cool. I don't know anything about this. Basically, we have a civil engineer, Jeff Marr, who's a director at St. Anthony Falls Lab. We have Andy Riesgraf, who your position is here. It's not a faculty position. Remind me of this. Research associate. Some of you may know Andy though. He got his master's here with Peter Sorensen, working on invasive carp. And they have some really cool work that they're getting started here, looking at something maybe we don't think of, but boats in lakes and what they will do with the turbulence. We have these boats with these large motors and lakes that may be really quite shallow in places, but enough to have a boat. How does that disturbance to the water column is what they're going to talk about today. Basically, they're looking at how it affects sediments and possibly like ecosystem dynamics, basically down at the layer of the benthos, so to speak. Yeah. And I'll turn it over to you all now. And yeah.
Hey everybody, thank you. My name is Jeff Marr. I'm a civil engineer by training, and I work at the St. Anthony Falls Lab. Andy Riesgraf, you'll hear from mostly today, and thanks for spending an hour with us to talk about some of the research we're doing at St. Anthony Falls. Holy buckets. I'll just stand back. Anybody been to St. Anthony Falls itself, the falls, or the St. Anthony Falls Lab? So we're located, this map shows just the Twin Cities, right? The river coming through the cities. The star is where we are right now, St. Paul campus. And, we're going to zoom in on the falls itself. So lots of interesting history here. If you haven't learned about the history of St. Anthony Falls and its geologic history, come and learn about it. It's super interesting. We're actually located right next to the falls. We're built in 1938, so we're 87 years this week, where we're doing hydraulic research and other kinds of water-related research, and happy to talk about that too at any point. We use the river in our research. We take the 45 feet of natural water head that's there and it flows through our building. So we're doing a lot of different kinds of work on lakes and rivers and fundamental topics. But today we're going to talk about work we've done in the field. Who's heard of wakeboat? Anybody surfed before? Wake surf yourself? Okay. So there's some familiarity with it, and Andy will talk more about these boats themselves. But what we're going to do is we've been studying for a number of years recreational boating in Minnesota and the kind of the upper Midwest. And the motivation here is really for us, we're in an applied research group. I'm not a faculty at the university. I'm also a research engineer. And we work with problems that impact Minnesotans or our natural resources. We started getting calls in kind of 2019 about these boats. Do you know what a wake boat is? Do you see what they're doing to our lake? And we heard kind of common themes. So we heard a lot about adverse environmental impacts, people observing on their property at their lake cabin or wherever, they're seeing turbidity, they're seeing damage, shoreline loss, and so forth. They're seeing property damage. They're seeing their shorelines actually eroding away, riprap that they paid lots of money for getting destroyed and kind of falling apart. Safety is a big issue we still hear about today. People out on the water when there's surfing going on and their boats are getting rocked around. We've heard of people getting injured, not seeing a wave coming and actually harming their body, people being thrown around. And then a big one is shared use of the natural resources themselves, whether it's mostly lakes, but can be the rivers and pools where people want to be out kayaking. And as soon as there's the surfing activity happening, they can no longer enjoy the recreation that they want to do. And that's an issue for public waters, right? So we did a little bit of work. There's really very little published information that has to do with lakes and boats. There's a lot of work out there on how boat wakes and their props impact like a larger ferry boats or are kind of larger naval vessels, but nothing at the recreational scale. And so that's where we come in. As researchers, we can provide well-designed research and data that people can use. So that's how we kind of saw our role here, is producing information that people very, very much need and get it out to folks. So that led to us forming this new program at SAFL St. Anthony Falls Lab called the Healthy Waters Initiative, where we established this soon after. And it's a research endeavor that we're trying to do to really focus in on the applied problems that are of interest in Minnesota. So our Minnesota aquatic resources, and that's going to overlap with a lot of your interests as well. What's unique about it is we're trying to focus on a single topic for a number of years, not forever, but 4 to 5 years, really dig in on a topic and then try to get that information out to people. Our focus right now is on recreational boats, and we're going to be doing that for another year here. So we're looking at characterizing recreational power boats, their hydrodynamics, which what I mean by that is the waves they produce, and also the phenomena underwater, which you'll hear about today, and investigate impacts on the environment. If you want to check out our program, there's the site. So we're 3 phases into this program. Phase 1 was done out in the west suburbs on a lake called Lake Independence, where we studied waves that are produced, the divergent waves that come off the hull. Divergent waves are the waves you see when they kind of come off laterally off a boat hull. We studied those, how big they are, how much energy they are, and we published that in 2022. And what's interesting is this is published not in a journal. We chose to review this independently with subject matter experts, and then we published it as a gray paper through the St. Anthony Falls publication, so that anybody, any mom and pop on a lake up north, lake associations that don't have access to journals can download this. And you can see the number, 19,000 people have downloaded this report. Not just in Minnesota, we're seeing it downloaded across the world, really, as this topic is important. We just published this summer our second report, which you'll hear about today. We call it phase 2, which is going to look at the phenomena that happen under the water when these boats are moving around. And Andy just checked, the 3,000 people have downloaded that. And there's also YouTube videos that you'll see today that we can't really track their downloads, but we think those are probably going far and wide. The third phase, we're going to be working on this winter. Data is collected. We're looking at trying to look at characteristics of boat-generated waves versus wind-generated waves, which is one of the big topics. What you'll hear from people saying, well, what about a big storm wave? Isn't that as important as a large boat wave? Storm waves can happen over 5-8 hours. How does that compare to a couple hours of big boat waves? And so that's a topic we're going to be working on over the winter and writing that up. So let's dive in a little bit. We're going to be talking about phenomena that happen produced by these boats moving across the water. And these are common features. What's beautiful about these waveforms is you've seen them with boats, but you've also seen them with loons swimming by, or any kind of disturbance forms these wave patterns. And we're going to talk about different waves. I already mentioned divergent waves coming out laterally from the boat. Today, we're going to talk about bow and stern pressure waves. We're going to talk about transverse waves, which you can see in this picture. They kind of come off the back of the boat, and they actually follow the boat in the direction of the boat travel. And those are less familiar to people. And then we're going to talk about propeller wash, the force that the propeller is actually pushing down in the water. And I'm going to skip some of it. One point I'd like to make is all of these phenomena they've been studied for eons, right? People have been trying to understand, they recognize the beauty of these features, and the physics behind them is really interesting and complex. We're not going to talk about that today. But there's a lot to study in all of that as well. So this slide summarizes in a kind of a cross section what we're going to be really looking at today. It's a summary of all the phenomena that we observed in our work and our team under the water. So we have a boat moving from right to left here, and it's producing a number of phenomena. On the left, the first thing we're going to see is the green and the purple are bow pressure waves, what we call bow and stern waves. And those are phenomena that are really quick that happen. So as the boat's moving, it's actually pressing the water down and forward, and that's felt throughout the water column. It actually creates motion that's like one single wave. And we'll see that phenomena in our data. And that actually moves along with the boat. So you can think of, if people are familiar with a shock wave or a sonic boom that an aircraft might make, it's kind of that same feature. It's this pressure that's following the boat and moving along. It actually penetrates quite deep. Second are these transverse waves. So when we're in a certain condition that Andy will talk about, happens to be when the boats are surfing, it's a slower speed. There's a wave called transverse waves that form off the back of the boat. And you've seen this when you've been in boats, you look in the back, it seems to be following the boat. So you don't really think of it as a wave when you're a passenger, but it is a wave that's moving along with the boat in a wave train. And those are also features that go very deep, and they can be pretty powerful. So that's a transverse wave. And you'll see in red there, that wave isn't going to happen when we're hydroplaning. When we're moving really fast, those waves can't exist. And the final is the propeller wash. In order for this boat to move forward, right, there has to be a force pushing down in the water. That's what the prop does. It bites the water and drives a jet down in the water. And so it's very powerful for a big boat. And so we're studying that phenomena, how deep it goes into the water column, and when does it interact with the bottom? When does it interact with vegetation? And some interesting things about this with our boats, all of our boats, most modern boats now are injecting the exhaust that comes out of the engine, right? We're burning gasoline, it forms a gas. What do they do with that? In our cars, we kick it out our muffler, right? In a boat, that's kicked in a muffler that's below the water surface. And so there's actually gas injected right in front of the prop, and it gets driven down, forms bubbles, and that has an interesting impact on what we're seeing. So those are some phenomena just to introduce those, and then how we use the boat is going to be really important. And Andy will talk a lot about these modes of operation when he's showing you our data. So we're going to introduce a few. So just try to hang with me here. Displacement mode is a type of boat movement when we're moving pretty slow. So if you're just pushing off from your dock, or you're kind of sightseeing really slowly around a lake, it's called displacement mode. The whole boat is kind of supported by water and the displacement forces that are buoyancy forces that are lifting the boat up. So leisure cruising, maneuvering. For the boats we're studying, which are all kind of under 20 to 30 feet long, you can see the speed there, less than 10 miles an hour, so pretty slow. Who's water skied before? So that water ski or tubing is a third mode operation called planing. We call it planing, hydroplaning. The boat is moving fast enough where it's generating forces on the hull that actually lift the boat up on the water, right? When you plane, you can feel your boat just skipping on the water. And that's done at fast speed. So water skiing, tubing, wakeboarding, and fast cruising are all examples of planing mode. And then there's this transition. We call it semi-displacement, where you're just transitioning from displacement up onto hydroplaning. And if you've driven a water skier before, you know this phenomenon where your boat is actually lifting out of the water. That's a transition. It is called semi-displacement. It actually happens with the most drag on the hull of the boat. It requires the most power to push the boat forward. And this happens to be where surfing happens. When a wake boat is in surfing mode, it's running at this condition because it also produces a really large wake on the back of the boat that you can actually surf on. So those are the three kind of conditions we're going to look at in our study. So on to our study, this phase 2 work. Our goals here are to identify the hydrodynamics. So the phenomena that I just introduced, we call the hydrodynamics, the water moving, how it's moved and what forces it to move, and how deep that goes and in what mode of operation we see it. We're going to investigate how deep these phenomena go and the velocities that are produced, and kind of the things that we would look at from an engineering lens. And then, yeah, that's enough on that. And then our goal is to try to get a look at this information. So you'll see we successfully deployed underwater cameras where we can actually observe how these phenomena play out with our eyes. So with that, I just want to make one last statement before Andy takes the floor. This is again, our perspective as a team, and Andy and I got to work with, there's 3 or 4 others in our group, so it's not just the 2 of us that did this work, is we come at this from probably an engineering perspective. I mean, Andy is our living animal person for the most part, but we're looking at velocities, we're looking at forces, and we're seeing things suspended. But we're a University of Minnesota lab. We want to just, one of the reasons it's exciting to be here is to share our work, but also invite collaborations. You all see environmental systems, ecology, vegetation, whatever it is, fish, organisms, more broadly than some of our group, especially me. So we'd love to talk more about, you'll see some of the disruption that's going to happen in the environment. But I think this is a really important topic for those of us that live and love Minnesota, Wisconsin lakes, natural glacial lakes that are so rare. How is our use affecting these lakes? We think that it's a pretty severe impact. And so we really need to it's kind of a call to action to say, this is a topic, we need more help. We need more minds thinking about what these impacts mean to the environment. So I just want to say that kind of soapbox piece, turn it to Andy to talk about the work.
All right, so yeah, my name's Andy Riesgraf. I come out of the Fisheries Wildlife Conservation Biology Department. Finished my master's in 2020, and since then I've been with SAFL here working on this specific project. So all that to say, if you're in FWCB, there are other avenues outside of just like where you can get involved with research and see it kind of work its way back into fisheries and wildlife conservation biology. So, all right, so I'm going to talk about the actual like test setup, some of our findings, and then our recommendations. So this is the slide just showing that our test site. So in the middle there, this is at Lake Minnetonka. If you're familiar, Lake Minnetonka's got a whole bunch of bays. But in 2022, our test was in North Arm Bay on the left side there, and in 2023 it was in Maxwell Bay on the right here. Just trying to show here with these 2 images on the left and right is that we ended up sinking sensors on the lake bottom at 2 different depths. And then we would drive the boats in a single straight line over the sensors a number of times to hit those different sensors at different depths. So I'm going to talk a little bit here about the sensors that we used. So again, bottom mounted sensors. The first one is called an acoustic Doppler current profiler. And from here on out, I'm just going to refer to it as an ADCP. And what this, in 2022, it was in 27 feet of water, and in 2023, it was in 14 feet of water. And these are our 2 deeper depths for each of those years. And what the ADCP does is it's upward looking. So it's looking through the entire water column, and it's measuring the horizontal and vertical velocities throughout that entire water column. The other sensor is called an ADV, or acoustic Doppler velocimeter. And this was installed at the shallower 2 depths for each year. So in 2026, or in 2022, it was in 16 feet of water. 2023 was in 9 feet of water. And this is downward looking. We basically, if you can envision just like the size of a marble, right at the lake bed, and that little marble is the area that's being measured, specifically the horizontal water velocities. And in the picture here, you see the red buoys and anchors and anchor lines. And when that's deployed, it looks like this. So it basically created a 20-foot goalpost that the boat driver is able to see coming up ahead, and to ensure that they're driving right over the top of that sensor. Also in 2023, we added some GoPro cameras to just be able to see, actually what's going on down there. And we'll look at some of those videos in a little bit. So our test boats, over the 2 years, we ended up testing 7 different recreational boats, broken up into 3 different boat categories or boat types. There's deck boats, bow riders, and then the wake boats. And these are all boats that are very commonly used on inland lakes, including Minnesota and Midwest. And I want to point out here that for the wake boats, there's these additional characteristics of the boat that are unique, and they're actually specifically designed to create large waves and large waves that you can surf on. And they include ballast tanks. So that's a capability of bringing on additional water weight onto the boat to create more displacement so that boat can sit further in the water and plow more water. Then they have these things called trim plates, which are basically just tabs on either side of the boat. And when the tab is deployed, it can shape that wave and make it actually smoother so that you can surf on it. They're actually very sophisticated. Well, they're not sophisticated, but what they can do is sophisticated where the surfer could actually hit a button on their watch and change the side of the boat that becomes smooth, and you can transition as you're surfing. They're very sophisticated boats. And then the last one is called a wake shaper, or sorry, a trim flake or hydrofoil, and that's a plate that comes down on the back of the boat to also pull that boat down into the water even further, the back of that boat. Again, with the goal of creating a larger wave. So in 2022, these are the boats we tested. One deck boat and 2 bow riders, pretty standard sizes for the deck boat and this first bow rider. But you'll see there that the cruiser yacht is a monster boat. It's a yacht. It's 760 horsepower, 35 feet long, 11 feet wide. You could sleep in the thing. And we wanted a big size boat to be able to compare to smaller boats and be able to compare to the wake boats, which are specifically designed for those big waves. 2023, again, a deck boat and a bow rider, very typical sizes, the 2,000 to 3,000 pound range. And then in 2022 and 2023, we tested the wake boats as well, both years. So when the boats are driving and we're testing them, they're driving in their under their typical modes of operation. And Jeff talked about the 3 modes, right? Displacement, semi-displacement, and planing. Well, condition 1 is what we're calling the first condition that we tested. For the non-wake boats and the wake surf boats, that's in planing mode, up on plane. For condition 2, though, for the non-wake boats, that's that slow cruising displacement speed. And for the wake boats, that's in semi-displacement or surfing speed. Your non-wake surf boats are not going to typically be in that semi-displacement mode. They're never just going around the lake, I'm going to plow water to plow water. They're either slow cruise or fast cruise. So for when we tested each condition, the boats were tested in a single day. And the boats made 5 passes in that straight line. And the colored lines, they're actual, we had an onboard GPS system that was precisely tracking our movements, and those are the actual plotted data points for each of the passes for just one boat. We had a start buoy and an end buoy, and when we were between those buoys, the boat was at its testing speed in conditions. Between each pass, we waited 15 minutes, and the reason for that is we wanted to allow any disturbances that we're making in the water column or at the lake bed to have an ability to get back to a steady state before we came and went through again. So we would make our pass, and then we would just do a slow loop around, get back to the starting, and we would do it again 15 minutes later. Also, between condition 1 and condition 2 testing, we always did condition 1 first, which is on plane, because we hypothesized that we'd be making less disruption to the water column and lake bed on plane. So we always did that condition first. And we also had a 1 hour waiting period between condition 1 and condition 2 testing. So condition 1 was usually in the morning, Condition 2 is usually in the afternoon. I'm gonna dive into some data and results now, but this is a big report. It's got 81 pages of data analysis and results. So it's just far too much to get into today in this talk. So we just kind of pulled out some key figures to show you that's really showing the difference between the non-wake boats and the wake surf boats. So the ADCP, again, that's that upward looking sensor, and it has the capability of creating echograms. So it's very similar to if your fish finder, right? It's sending a signal back, it's hitting off of an object in the water, usually a fish, it's returning that, and it's showing you the depth of the fish and approximately where it is. And so the emitted sound waves of the echogram, the echo capability gave us really nice figures, a strong signal of the exhaust bubbles that Jeff was talking about, and any sediment that is resuspended off the bottom. And so what we're here looking at the left, both of these are actually a wake boat in wake surf mode at that 14-foot depth, so that 2023 depth. Just trying to show here that there's a really strong signal. And so for each of the 5 passes, let me back up. The black line is actually, we set a threshold, a decibel threshold, to kind of get an outline of confidence of like where those bubbles are no longer there and where they are there. And so that's the black line. And so for each of the 5 passes, we would take those the black lines, and we would we would get an average bubble depth and extent. So this is what I'm showing here. So on condition 1 on the left is planing mode. This is a good time to kind of explain colors. The colors of each boat are going to be carried out through the rest of the figures. So the one, if you could pick your favorite boat, but the wake boat ones, just to point out, are purple and blue. That really big cruiser yacht, the 14,000-pound yacht, is pink. And then your smaller deck boat and bow rider, the 2,000-pound boats, are going to be your red, green, and orange. So what we see here in planning mode is that the bubbles, went down to about 7-8 feet, and they lasted for only about a minute and a half. Whereas in condition 2, so cruise or that displacement mode or semi-displacement mode, the wake boats you can see are down to 9-10 feet of penetration depth. So a little bit deeper. So now this is the suspended sediment, and the only boat that created suspended sediment that was detected by our ADCP was the wake boats in wake surfing mode. At the 27 feet in 2022, we saw no evidence of resuspension for any boat, any condition, anything. But at the 14-foot location, we did see, again, only the wake boat in condition 2. We see resuspension. And what we see here on the left is the 5 passes. It's chaotic. You can imagine, sediment going everywhere. And so it's messy, but there is a signal of resuspension. And so what we did over here on the right is just a box plot of the 5 passes, picking off the maximum of each one of those passes, just showing that the maximum sediment resuspension off the lake bed for the Natique on the left is about, the average would be 6 feet, and on the right there about, I don't know, a little close to 5 feet of resuspension in the water column. So now I'm going to dive a little bit into velocity data. So I just talked about the echograms that had nothing to do with velocity. Again, that was just the echo. So velocity here, and I'm just going to talk about the ADV. So that really near bed horizontal velocity. And this is an example of what the data would look like. We would see the boat go by, and there'd be the signal of an oscillating wave. And you can see on the left, very far left here of the signal, you got the bow wave, which is that first maximum. and the stern wave, which would be the second, like downward maximum. So yeah, the first two points there are the bow and the stern. And then the remainder of the signal is that transverse wave that Jeff talked about. If it's present, as recall, transverse waves are not there during planning mode. And then if they are, that combined with the propeller wash, if the transverse waves are there, we had to figure out a way to decouple those, to separate out the transverse wave from the propeller wash. I'm not going to get into that method. It's in the report, but a little complicated, but we were able to successfully tease out those two different signals. All right, so there's some quick figures here. It's the same colors like I talked about. These are box plots, so pulling out the maximums and of the 5 passes and just showing a box plot. So for the bow waves, this is going to be condition 1 planning. On the left is this is all bow waves, but on the left is the 16-foot depth, and on the right, 9-foot depth. Basically, we put some thresholds on there for sediment disturbance. So at about approaching 0.3 feet per second is when a coarse silt would start to be disturbed. And then up to a coarse sand, which is approaching 0.6 feet per second. Usually things are not in feet per second, but our audience was the general public, so we converted everything to feet per second. Not much going on. Yeah, the big cruiser yacht was above course silt there, but everything else is below that. We look at the stern wave, again, that's that wave that's rebounding right behind the boat. Again, same thing, nothing really happening when in planning mode. Now, when we go to condition 2, again, leisurely cruise for non-wake boats, surfing for wake boats. Same type of figures. The bow wave, you can see that we have elevated velocities, especially at the 9-foot depth. If we look at this, you'll look at actually the axis changes. Point up to point A, we're actually now the 1.6 feet per second. And that's because the wake boats at 9 feet had such great maximum velocities, well above the disturbance of coarse sand. And these are the horizontal velocities again, so just horizontal relative to the lake bottom. Transverse waves, again, only occur in condition 2. And again, we see the wake boats having elevated when compared to the non-wake boats. The propeller wash, was only measurable for the 2 wake boats during condition 2, so during surfing at the 9-foot 2023 location. So and this is at the lake bed. So at the deeper location, at the 16-foot location in 2022, there was no evidence of propeller wash reaching the bottom for any boat, any condition. So now the fun part, videos. Back to those GoPro cameras in 2023. I'm just going to set this up here. So this is going to be condition 1 planing. It is going to be the Sea Ray, which was a bow rider. So about that 2,000-pound weight boat, very common boat. What we're going to see is just a really quick bow and stern wave, and you'll see it. And then there'll be no exhaust bubbles because the bubbles did not reach down to 9 feet. There'll be no resuspension of any bed sediment. We're on plane, so there's no transverse waves, so you're not going to see any of that. And propeller wash, I think I already said, is not seen, observed. Sorry, I gotta turn this thing off. So the boat's coming from left to right. So there's the bow, stern, and then nothing else. Hold on, it's not letting me use my mouse. Yeah, but it doesn't let me click. Um, There we go. Okay. Nope, now I'm on condition 2. There we go. Condition 1. So now this will be another camera view. What? There we go. Okay. This is at the 14-foot depth now. So we just went over the 9-foot. We're approaching the 14-foot. Again, this time the camera is going to be, the boat's going to be going right overhead. So again, we see that bow and stern wave, but nothing else after that. And there was some disturbance to that lake bed. But no resuspension. There's like disturbance, but no resuspension. Now this is condition 2 for that same exact boat. So now this boat is going slow in that displacement mode. Same view, boats coming from left to right. 9 feet of water. So everything happened a little bit slower because the boat's moving slower, but same view overhead.